everyone. My name is Dan. Nice to meet you all. Look forward to an interactive session. I've got, although the byline sounds a bit like a statement, it's actually meant as a question. How do we nurture and sustain empathy? I do want to, at the outset, congratulate the organizers and everyone who's here, because these are complex questions and can only really be answered in an interdisciplinary way. And so, to paraphrase a teacher of mine, it's Greenberg, it doesn't matter which part of academia you come from as long as you're ashamed of it. Meaning we should all reach outside of our comfort zone into that zone of proximal development, because that's where we can really learn something from each other. So I'm going to try to step outside of my comfort zone this morning into what is hopefully a zone of proximal development with you, and try to bring my perspective on these topics, which I know you've already talked about over 2 workshops, and bring the neuroscience angle, but hopefully in a way that speaks to the themes that you're interested in. So I'd like to just give a bit of a map, first of all, where we a bit of a map of the session. So questions for us to consider this morning. The question I'd like to keep in mind, in the back of your mind, is how to achieve a balance of empathy. And I'll explain a bit more what I mean by that. And then I have 3 questions for us to look at in detail. The first is, where does empathy come from? Speaking across a number of disciplines, including neuroscience, but also other related areas of inquiry like psychology, anthropology. We're going to look at some of that evidence. The second question I'd like us to consider is, how does learning happen? Because if we want to foster change, behavioral change in individuals, that requires us to understand a bit about learning mechanisms. And finally, how can we nurture and sustain empathy after we have identified a lack of it? So, I'd like to start with 2 stories. The first is a painting you may know by Peter Bruegel, although recent research has cast doubt on whether it is in fact a Peter Bruegel's work. It is certainly from the 16th century. And it depicts an agricultural scene, pastoral, a ship sailing off, and then 2 chaps, or 3 people working the land. And it's only when you really zoom in and look at it for a while that you notice that there is this flailing boy drowning in the middle of the picture. And it's quite arresting, because all of a sudden the whole scene changes and you realize you're not looking at a pastoral picture, but it's something else. And so W.H. Auden has a poem about this called Musée de Beaux-Arts. I'd like to read to you the final stanza. In Bruegel's Icarus, for instance, how everything turns away quite leisurely from the disaster. The ploughman may have heard the splash, the forsaken cry, but for him it was not an important failure. The sun shone as it had to on the white legs disappearing into the green water, and the expensive, delicate ship that must have seen something amazing, a boy falling out of the sky, had somewhere to go and sailed calmly on. W.H. Auden wrote this just in the years before the Second World War, and you can imagine how the politics of the time would have informed his reading of the painting. And I bring it to you because I think we're often a bit like that ship, somewhere to go, sailing calmly on, aware of disaster around us, but quite effective at keeping it out of our minds. So that's one story of empathy. I'd like to contrast it with a different story of empathy. This is a painting by Catherine Ross of the Turin horse and Nietzsche. You can just about make him out there in the top corner. So this relates to an episode that we're told happened in the year 1889. Nietzsche was living in Turin, in the Italian city, and he stepped out of his house one morning in a cold January morning, and he saw a coachman beat his horse, and he pushed through the crowds, and he embraced the horse, crying, sobbing uncontrollably. And this, the story says, was the start of his delirium, which lasted the 10 last years of his life, and he was looked after by his sister. And so it's a story of perhaps too much empathy, or empathy that's not effective, that is just an outpouring of emotion that doesn't, whilst it's touching, doesn't borders on the form of insanity. And so these two stories of lack of empathy, which I like to situate not in people who lack empathy, but in all of us, because I think there's always pain or disaster that we disregard. And the second story of empathy, perhaps overblown, just have those two counts in mind as we go through the rest of the slides. So one thing just to say at the outset, although I come from a neuroscientific sort of perspective, there's obviously huge social, historical, political aspects when it comes to what we might call evil or lack of empathy. And I just bring you Sigmund Bauman at the outset just to say that ideology, belief in progress, belief that you're creating an ideal society, those ideas of modernism, and of course when it goes into extreme ideology, as we see with certainly ISIS today, that is always part of what warps the mind. I'd like to put that to one side and try to focus on the basic processes of empathy in the brain. And this quote from Woody Allen in the character of Frederick in Hannah and Her Sisters, I think, encapsulates what I want to, where I like to situate myself. And he says, the reason they can never answer the question, how could it possibly happen, he's speaking here about genocide, Holocaust, is that it's the wrong question. Says Frederick in that film. Given what people are, the question is, why doesn't it happen more often? And it's this phrase here, given what people are, which is obviously Woody Allen's view of human nature, but I think it requires a bit of, for us, I think, to look into what that really means and to try to get a grasp of that, because it does matter in terms of how we approach the problem of empathy. So, where does empathy come from? I wanted to bring you to this slide, which is my favorite slide in the whole world. I'd like to explain it to you. On the y-axis, you have time. 0 is time now, and this is 2 million years ago. And then across the slide, you have different regions of the world, so Europe, Africa, Asia, and the Americas. And essentially, it's a map of the spread of populations through the last 2 million years. So early humans lived in Africa, quite a small group, and there was a foray into Asia and a foray into Europe, but essentially they didn't survive, they died out. But then there was a long period where early humans lived in Asia until 200,000 or 100,000 years ago. And again, you can see how small groups are trying to make a living in a difficult climate and often not succeeding. What I'm interested in is what happens here. At this point, something seems to happen. Something seems to change the picture. You have 2 million years of small groups, not much change, not much ability to survive in a hostile world, and all of a sudden, some 40, 50,000 years ago, there's a big change. And I believe that the answer to that comes from what you might call cognitive archaeology, which is how our brains changed. So what happened at that point was, for various reasons, the cortex of the brain expanded, and it enabled us to do things that we couldn't do before. And the most important thing that it enabled us to do was to cooperate. And so the big difference between early modern humans and our species, our subtype of human beings is the size of especially the cortex of the brain. And the kinds of things that we see from this period, and how this is relevant in our context today, is this huge spread of cave paintings across many different parts of the world. Representation, which is obviously key to transmission of culture and learning, enabled early modern humans to gain information from their ancestors, from their non-kin, and it enabled them to increase their survival potential. We also have the first evidence of representational art and of writing from this period. And so all of a sudden, what the development of the neocortex does is actually to create a cultural revolution. And that is actually what enables the early humans to spread and be so successful, to dominate the planet. So that is evidence, or at least an account of how the early history of the brain might inform our discussion today. The second thread of argument that I wanted to bring in is evidence from developmental psychology. So this is the famous, one of the simplest and most powerful experiments in developmental psychology from René Bayardo. And what they did was they placed babies, 3 months old, 4 months old, in front of a drawbridge that was moving back and forth, and they got used to looking at it and understand what it was. It was a real physical object. And then they showed them, they put a block in front of the drawbridge. And so when the drawbridge would hit the block, it would stop. And then they would do a trick where it looked like a block was there, and the drawbridge went through it. And this is what they call an impossible physical event. And what they found was that the heart rate of these very young babies increased when they saw what you might call an impossible physical event. And their conclusion was that we're born with certain folk physics in our brains. We're born with certain expectations about how the world works, about how solid objects interact with each other. And I think that experiment, and there's been a whole literature on the intellectual capacities of babies, really has shown that we're born with a number of abilities. Certainly, they need to be trained, like language needs to be actualized, but we are born with a number, like a toolkit of the brain. And so, one key enabler of that toolkit is attachment. Very briefly, this graph, another famous graph in the early psychological literature, this is Main and Weston, 1981, based on Ainsworth's strange situation. So very quickly you have a room with a stranger. In this case it was a children's entertainer dressed up like a clown, and three months old babies were left with the stranger, and their behavior was rated in terms of their social responsiveness and how they were able to let go of their primary caregiver, and whether they would be able to have a healthy relationship with an adult. And so what this graph shows is that a baby who is deemed to be secure with both parents is much better at interacting with a stranger in an appropriate way than a child who's insecure with both parents. I think we can read this now in 2015, perhaps more like primary caregivers and secondary caregivers rather than mother and father. But that was the situation in 1981 when this came out. And so the takeaway point from this slide is to say that in Simon Baron Cohen's phrase, attachment is like a pot of gold that we're given if we're that lucky, and it enables us to interact confidently with the world, and that is at the heart of our emotional development, of which empathy is obviously a key part. The third strand of evidence I wanted to present to you is evidence from developmental anthropology or psychological anthropology, and this is Michael Tomasello, his study where he compared the behavior of children in very different contexts. So an affluent Canadian suburb context, favela in it's actually a rural Peru, not Brazil, and a slum outside Delhi. And these are his findings. The task was helping. The experimenter do a particular task, offering to help, and these are a number of times that the child helped within a 10-minute period, and the numbers are the ages. And so at 18 months and 24 months, the Canadian children were on average helping 2 to 4 times, and then in India, 18 months and 24 months, and in Peru as well. And although there is this slightly late onset, but then compensation in the Canadian cohort, I think what the takeaway message from this slide is that on average, the development of empathetic skills in children happens roughly at the same time, irrespective of whether your parents are illiterate or if they're wealthy. So again, just to emphasize that point, that there are certain aspects of our pro-social behavior which appear to be near universal. Of course, modern neuroscience is looking at this often from a brain anatomy perspective, and that's some of the evidence that I wanted to share with you in the next few slides. And just to say at the beginning that throughout, one of the things that at that point, when what's called the Great Leap Forward, when the neocortex grew, one of the things that clearly must have been part of that revolution was the development of complex language and complex emotions. And so I thought it is just worth spending a moment to recognize how incredible it is that we have the ability to create words in the way that we do, and the amount of machinery that goes into it. It's not enough just to have a Broca's area, an area that produces language. You also need to have a Wernicke's area to hear yourself speaking in order to check your enunciation. You need to have the motor cortex to actually move the machinery of speech. And then you have to have the machinery that is able to make sounds that can be different enough to actually make complex speech happen. And of course, again, just to say, modern neuroscience, especially using imaging techniques, are now looking at how a whole host of emotions that are quite complex and quite human, you might say. So one thing that comes in the development of particularly empathy, but of a lot of different cognitive skills are, it's number one, play, and number two, the idea of critical periods. And I just wanted to remind us how important play is in children's development, how much of children's play is actually imaginative play and relational play, and pretending that inanimate objects have feelings and personalities. It's often something we overlook, that every child has an inanimate object that they have ensouled. What does that mean? How is that a key prop in their development? And to say that there are probably a number of critical periods where this happens. It's best comparable to language, where if you don't learn a language in a particular time period, you can learn it later, but you learn it as a second language. And I think that's true as well for aspects of morality. If you've had a childhood with disruptive attachment, neglect, or trauma, you will struggle. You might struggle. And you may have to learn to trust other people, almost like a second language. That lack of trust will always be there in many cases. That's not to say that it's only children who learn, and at the end of childhood the chips fall where they might. This is an experiment from a lab in America where they taught, where they gave research volunteers a 3D experience. So you spend half an hour pretending that you're either a superhero flying over a city to give insulin to a kid who needs urgent medical assistance, or you spend half an hour just flying over a city and having that sort of 3D thrill. That wasn't actually the experiment. After the experiment, there was a sort of big debrief where the researcher sat down with the volunteer and asked him a number of questions, during which the researcher accidentally made a cup of pens fall to the floor, and the people who had pretended that they were superheroes were twice as likely to help. What does that mean? It means that, I don't know, but I leave it to you to decide, to draw your own conclusions, but I think it means that the stories we tell ourselves about ourselves do matter. And that's obviously a highly contrived example, but I think we can think of many examples, can't we, about how your own sense of a purpose and entitlement and role and in the world does make a huge difference to how you act. So just to summarize then, or to bring this together, the medial prefrontal cortex has a key role in social behavior, in imbuing other people with mental states. A lot of Sam Baron-Cohen's work is on the executive function of the prefrontal medial cortex. The anterior cingulate does a lot of comparison between old and new, evaluating decision-making. And the ventromedial prefrontal cortex, which sits sort of behind the eyes, is key to reward and control of risk-related behaviors. The insula, which also is part of the neocortex, has a key role in our own understanding of our bodily feelings. So if we experience stress, the insula will be aware of it and tag memories and events accordingly. And the posterior superior temporal sulcus has, again, a key role in social perception. I'd like to focus on the next few slides on an area that I've been, I've been interested in for a number of years, which is the amygdala, which sits at the base of the brain. It's called amygdala because amygdala means almond in Greek, and it has a sort of almond-like shape, although many things in the brain happen on. The amygdala has a number of functions. I think of it like the part of the brain that tags experiences and memories with emotional content, like a flag that you might put on an urgent email. And so it's key in learning about effective relationships and behaviors. So in 1998, I joined UCL as a researcher, and I spent my first year working on the grant from the Department of Health, spending a lot of time visiting inmates at Wormwood Scrubs. And the idea with the project was really to try to understand how people who are at the very high end of antisocial behavior, what we can do to help them to understand the deficit that they appear to be having. So my work was confined to what's called a lifer wing. And what we did was these are what's called Ekman faces, so faces that display different emotions, so fear, sadness, neutral, and happiness. And one of the experiments that we did was to use what's called galvanic skin responses to look at the response, physiological response, when you're faced with a number of different pictures. And so one experiment, this is James Blair's work, who was my supervisor at the time, was to show inmates a neutral picture, a picture that had some kind of action sequence to it, and then a picture of it was not this photo, it was a different photograph of a boy who looked like he lost his mummy, etc. And what Blair was able to show was that the response, the galvanic skin response, was comparable to age-matched inmate controls in the two first conditions. So they mounted galvanic skin response to, say, the exciting picture, but it was basically flat in response to the sad, fearful picture. And Blair's suggestion from that series of experiments was to say that there's this sort of blind spot that some individuals have when it comes to perceiving the emotional distress of others. Now, one question that animated us a lot at that time was, is that something that is learned, or is it a blind spot that you're born with and that explains your behavior? And I don't think we can pretend to know the answer to that. So that is one of the key questions. But a lot of the literature in the subsequent decade has helped us ask the question in more sophisticated ways. This is one example. This is a group in Finland who again looked at high antisocial behavior displayed in inmates. This is a reconstruction of the amygdala. It's a very strange way of displaying it, but essentially they pulled out the response from the fMRI scan, and quantified it, and then color-coded it. So the redder the signal shows an increase in activation, and the colder the colors show a decrease in activation. And overall, there was a decrease in activation if you compared a person who scored highly to a person who scored low. So this is just a summary, and there's another slide in a minute that brings that out. Just to put it all in one slide, what we know now about the amygdala is that it preferentially processes certain key emotions, such as fear, anger, and sadness, that it is reduced in individuals who display very high rates of antisocial personality type behavior, that it's also reduced in adolescents with similar behaviors. And interestingly, recently there's been some work on showing that in major depression, the amygdala might be overactive. So you can imagine how if your amygdala is overactive and you take over yourself all the troubles of everyone around you, that might be a factor in a complex disease like depression. So the second part of my presentation is now to take all of that learning that we've, all of those insights that we've gathered from the sort of a whiz through of the neuroscience literature, and to ask the question, okay, so let's say you have a person who, for whatever reason, is displaying an empathy deficit. How can you change that? How can that be altered? And to effectively do that kind of work, I think it's useful to just have a grasp of the kinds of the ways in which the brain changes. And I think one of the great successes of the neuroscience literature over the last 30 years has been there's been a vast amount of work done on how the brain changes, and it's actually been quite. We now know a lot more, and there's a number of mechanisms that I think an effective program of intervention could incorporate in order to optimize their. So the first way in which the brain changes is through what's called synaptic plasticity. So you have in the brain all the neurons are interconnected, as we know. Each neuron has on average 2,000 connections to other neurons, so it's a vastly connected system, and that is done through synapses, and the synapse is essentially that place where two neurons meet, and across the synapse, neurotransmitters will, chemicals will move back and forth. The paradigm of associative learning that comes from Donald Hebb says that cells that fire together wire together, and what probably happens in early development is not only do connections between neurons that fire together become more stronger, but there's the vast amount of the sort of brain sculpting that happens is actually unused connections fall away. Fall away. And so that is what Robert Dunbar calls mind sculpting. Now, in terms of the morphological, so the shape-like changes that do occur, that we know occur in the brain, these are 4 types. A synapse might have increased numbers of receptors, so that's on the receiving, so information travels this way. I think of it like inside, I think of it like the English Channel. The inside cell information travels electrically. Across the synapse, it travels chemically and then again electrically here. And it's at this juncture that these changes happen. So increased numbers of synapses means that these 2 cells, these neurons, can speak to each other more effectively. You can release an increased number of neurotransmitter packages, again for the same reason. You can actually see how learning enables more terminals to be created, so you have more ports to log on to the, you might say, to the cell receiving signal, and then actually changing the receiving cell, making it thicker, more able to take in information is a 4th type. And there are others, and we'll look, this is looking at the way cells change, which is obviously a different level of investigation and what happens inside cells. We'll see in a minute. The second thing I just wanted to highlight, which I think is really exciting, is since 95 or so, there's been a lot of research on what's called neurogenesis, which is the creation of new neurons. So in the last 100 years or so, since Cajal's dictum that after early development there are no new neurons created in the brain, that's been shown in various ways to not be true. The adult human brain creates new neurons in response to environmental stimulus to a large extent, and some areas of the brain actually have 25% new neurons on a rolling basis. And this is just a picture from Elizabeth Gould's lab at Princeton, and the pink cells are all cells that are less than 3 months old. And this, before the early 90s, this was thought to be possible. How does it relate to changing behavior and making learning happen? Obviously, those are 2 different levels of understanding on the psychological and the neuron level. But it does, I think, give us it gives great promise in terms of how the brain can actually change in adulthood and throughout life. And then finally, wanted to just mention the importance of the environment to sort of zoom out for a bit. One of the experiments that we did when I was doing my PhD at Oxford was to look at enriched environment. So this is a not very enriched environment. It's a mouse that sits in a cage with no stimulus around it, and it contrasts very much to the kinds of enriched environments that we built for our experimental animals. So we created sort of a whole fairground of places where they could play and run around and be sociable. And what we found, and that's the reason for telling you, is that their learning improved. Their other labs have now shown that the rate of neurogenesis increases. And so, obviously, again, we're talking 2 different levels, but I think in the criminal justice system, where you put people essentially in a cage for a number of years without much stimulation, it is not perhaps that surprising that the recidivism rate is as high as it is, because there's no actual conflict that occurs. How can we make the environment where a person spends perhaps even a number of years into a learning experience is a big challenge. And then finally, which is more just to mention, just to sort of open the box of the cell, I spent 5 years of my life looking at this bit, and that we don't understand it. But I show you the slide just to show how complex this is, but also to say that the third type, so we spoke about synaptic plasticity, we spoke about neurogenesis, the third type of change that happens at the brain level is what's called epigenetic modification, which is essentially an editing of the DNA. So epigenetics, epi from the same word as epilogue, what comes after or around. Epigenetic are all that code and all that information that is attached to the genome that tells bits of DNA when to turn on, when to turn off. And it has a key role in the modification of the genome in response to the environment. So learning happens here, but deep inside the cell, there are epigenetic modifications that changes the way the efficacy of the cell. So those are 3 types of learning that I think inform how we create behavioral associations. Now, the third question for us to consider this morning is this question about how empathy can be nurtured and sustained. And here I really want to try to bring this into the restorative area. Again, an area slightly outside of my comfort zone, but hopefully the zone of proximal development. So I spent the last 2 years trying to learn about and practice the bit of restorative facilitation, and I've been absolutely blown away by the power of it and how it can reach people in a way that I don't think many other types of interventions can. As you will know, because you either facilitate this yourself or you've spent a lot of time looking at this in previous workshops, one of the key aspects of the restorative facilitation is the conferencing, often between victims and offenders, but as I'd like to show you in a minute, it doesn't always have to be in that context. What I think it does, and this is a slide that I've inherited or stolen from my restorative teacher, Janine Carroll, is that it is able to peel away these layers. So it goes beyond the behavior, even beyond, although it takes into account the thinking and the underlying emotions, and goes to the heart of that unmet need that might be at the heart of a person's dissocial behavior. And it is by reaching that point where the magic happens. That's where the gold is buried, as Janine would say. And I think that's something really important when it comes to people in the room who are very experienced at enabling that process to happen in a safe way, in a supportive way. If you can reach and understand that level in an individual, then the prospect of a change is possible. I like to think of conferencing within restorative justice a bit like an electroshock to the brain, because it's actually, as opposed to almost any other kind of psychological intervention, it is the kind of intervention that often just happens once, but can have profound consequences down the line. And I just wanted to include in our discussion Ivan Pavlov, the famous early learning theorist. And to tell a story about Pavlov, which I think is relevant, Pavlov lived in St. Petersburg, and his laboratory was next to the Volga River. And one spring, in the early part of the last century, the Volga River went over its banks and flooded the laboratory. And as you will remember, he had a number of dogs in cages that he was experimenting on. And because they were trapped in their cages, many dogs died, they drowned. Some dogs survived, and Pavlov, being Pavlov, set out to test the dogs who survived. And what he found was that the dogs who had survived had lost their stimulus response association. The trauma of near drowning had sort of reset their learning. Now, if that learning is a positive association, if that helps you in your life, then obviously the trauma can be very negative, as it often is. But I think of restorative justice and effective conferencing a bit like that it resets your expectations about yourself and enables you to think about your effects on others in a completely new way. So I'm sort of getting, I think, to the one thought that I wanted to leave you with today, which I think, which I hope to get your ideas and input on as well, because it's I think, for me, where the biggest question that I have in my mind. So the way I'd like to introduce it is this paper by John Lassetti, who's one of the big researchers out there, and his colleague Kent Keel. They're based at Chicago and New Mexico. And in this paper, they did a very interesting twist to what you might think of as the sort of standard empathy experiment. And so what they did in the first condition was to show a video of somebody suffering and a short episode of physical pain. So one of the conditions was somebody playing the piano, and accidentally the lid of the piano went over their hands. And so normal people, when they watch this, have a sort of big emotional, affective response. Their amygdala lights up, their galvanic skin response goes higher, and as you would expect. So these individuals that this group looked at were individuals who were scored low, middle, and high in terms of their antisocial behavior on a particular checklist called the HARE checklist. So what some people call psychopaths, I don't like to use the term, but that's what they use in the paper. So far so much that's not very surprising. People who scored highly on the HARE checklist didn't have much of a response in terms of their amygdala activity. So here you can see low, middle, and high in the black, imagining others, so looking at somebody and being told that they are the hands of another person, and you have essentially no response, certainly in the middle and the high scored social personality trait individuals. But what they then did, which I think is the key, is that they then told the person sitting in front of them that these hands are actually your hands. You're looking at a video of your own. I think they put the hands inside a contraption so you looked like you felt like you were playing piano, and all of a sudden you would look at the video and the thing would come crashing down your own hands. And their amygdala function was normal. Their amygdala response was was the same as people who are not deemed to be antisocial in any verifiable way. And what that means is that psychopaths, if you forgive the term, do have the machinery of empathy. It's just that they apply it to a very small circle, to a very limited, they've got an N of one, or maybe an N of, just their little family. And I think this is obviously true if you think of great evil people in world history, as well as in novels and films. They often look after their own, the Don Corleone type, no problem blowing the heads of an enemy, but obviously looking after their own or themselves to a great extent. So, what I like, the big question I like to leave you with today is the following: if it's true that the machinery is intact, but the application is faulty, that they extend it only to their little tiny circle and not beyond, then how we nurture and sustain empathy becomes a question of application. Actually, it's not about teaching these people or ourselves to feel empathetic. It's about teaching who to apply to, who's included in our circle. And the person who I think came closest to this idea is Peter Singer, who's an Australian moral philosopher, famous for embracing animal rights, which is relevant to this. And he has a book which is not so famous, from 1981, called The Expanding Circle. And in this book, he essentially makes the argument that human society is an expanding circle. The more we learn about each other, how the more connected we become, the more globalized the world becomes, the more we expand our moral circle. Now, I don't think that's always true. I think the circle often shrinks, and I think in parts of the world today, you only need to open the paper. There are places where the circle is perhaps expanding. Maybe what comes to mind is the recent Supreme Court decision in America, where all of a sudden sexuality became less of a barrier to certain types of legal procedures like marriage. But in other parts of the world, I think this circle is actually shrinking and becoming more constrained. And so I think there's an expanding and a contracting circle. And I think we all have this. And if you think back to the Bruegel's picture at the beginning, we all have people we define outside our circle of inclusion. And I think the power of a restorative justice process, of facilitation that is done well, is that it enables that circle to all of a sudden be expanded, to include the victim, to include the person who is the recipient of harm. So how can we take this this idea into other areas? So at UCLH, where I work, I've started a program which I call the In Your Shoes study, and what it is to use the concepts and the methodology of restorative justice in the health sector, because people are harmed in the health sector. I work at the Institute for Women's Health, where and Elizabeth Gareth Anderson, that includes the labour ward, and that's a very high risk. Obstetrics is a very high risk area of medicine, and every so often something happens. A patient is harmed through a mistake, almost never deliberate, obviously. But what happens now is that those people then go to a barrister, they sue the hospital. Half of the UCLH budget compensation budget is spent in obstetrics, in payouts, and that's often a process that doesn't leave anybody any happier or wiser. A patient might come to their barrister and say, I want justice, or I want the hospital to change, and I don't want this to happen to any other person. But what actually happens is that the barrister turns around if he's an honest, or he or she is an honest barrister, and says, I can't give you justice, I can give you compensation. And that is insufficient often, and frustrating. And it often doesn't lead to any change in the practice of the hospital, because once the lawyers are involved, as we know, it all becomes an adversarial situation. So in this study, what we're doing is we're taking women who have been the victims in some way of some kind of harm, non-deliberate harm in the hospital, and we bring them together with the actual person who was involved in their care, so a nurse or a doctor or an administrator who may have, slipped up. And the power of that is that the individual clinician, health professional, is able to see the consequences of their action, is able to change their behavior, hopefully, in a way that is much more effective than being told off. You have higher rates of people coming forward and saying, I did a mistake, because they know that this is in the context of learning and not in the context of punishment. And it gives the patient a whole different story to understand the pressures that the clinician or health professional was under in that particular situation. And so we're hopeful that this can be a nucleus of something that, taking in the same way as the restorative methodology has been taken into schools and very effectively been applied in housing associations and a number of other, it hasn't yet moved into health. Maybe that's something we can think of doing on a large scale. Finally, just to return to art at the end, to say this is my great key of dreams, which is also the front page of Tom Berger's famous book, Ways of Seeing. And the first line in that book is that we see the world first, and only secondary use words. Magritte is obviously playing with this because the words don't match the pictures. And I think this is, I just bring it as an example of how art and, of course, design can jolt us out of our habituated ways of thinking and open new avenues for looking at the world in a different way. This is Larson's take on the same idea. And so what I wanted to leave you with is this. How do we achieve a balance of empathy? Remember the two stories that we started off with, the boy in the water and Nietzsche's Turin horse. How can we find a good balance between those two extremes? So we looked at the evolutionary history of the brain, the early years with its importance of pro-social play and critical periods, and then lifelong learning potential. How learning happens in the brain, I presented just 3 different mechanisms, but I think it does matter in terms of how we work with individuals in terms of facilitating learning. So synaptic plasticity, neurogenesis, the creation of new neurons, and epigenetic modification, changing the actual way in which DNA is expressed. And then finally, nurturing and sustaining empathy. I think there's huge potential in the restorative approach. The question, I think, is how can you bring that into the mainstream? How can you expand the circle? And then to think of ways in which we can do this using our environment and the role of design. Finally, the very final thing, I just wanted to mention on a personal note, Joep Picard was a physician who lived in Amsterdam. He was completing medical school just before the war broke out. And then he started practicing in a clinic in his house. It was quite common in those days to have a clinic part of your house and you would see patients there. And when he built his clinic, just in 1939, he decided to create a double wall because he thought that war is coming and there might be a time when I need to hide somebody. An extraordinary thing to do. And in 1942, a young couple knocked on his door. They had been tipped off by the underground and said, "We're Jewish refugees. There's nowhere safe for us in Amsterdam. We've heard that you might be able to hide us." And the young couple, who were my grandparents, stayed in Joep Picard's wall for 18 months. They didn't leave the confines of his clinic. During the day, they would stay in the wall and sleep. And during the night, they would be able to be outside in the room. He shared his rations. So food was rationed. This is the 1944 was the hunger winter in Amsterdam. People were on less than 500 calories. He and his wife shared their very meager amount of food they were able to obtain, and he weighed everyone every day to ensure that nobody dropped below a body weight that was sustainable. I met Joep Picard at my grandma's 85th birthday, and I asked him the question that I had been asking, since I heard the story when I was a kid, which was, why did you do it? And Joep Picard, who was then an old man, sort of put his head to one side and smiled and said, I guess, as Freud would say, I did it for narcissistic reasons. I don't know what he meant by that. But I think there's something about a person
did it because it made him feel good?
Well, it's interesting, and that's what he claimed, but I don't believe him. He then died, and we tried to have him honored in Yad Vashem, which is the Holocaust Museum. And his family wrote back saying, our father has instructed us not to accept any honors on his behalf, he just did his duty. So that's, I think, a story of a man who got it right. The challenge for us is how to emulate that in our everyday life. Thank you.